This is an RJ45 style Ethernet surge protector, and the idea is that if you've got a long data cable passing maybe between buildings or just, anywhere that it's exposed that, electrical transients could be induced in it by lightning or other things, then by putting this in line with your data cable and the equipment that it's going to, and providing a good earth reference to this, a good ground reference for this connection, then this unit will theoretically shunt any transients. If it gets a really major lightning strike, it may destroy this unit, but hopefully in the process it would maybe short out. I'm not really sure because I've not seen inside this one yet. But this is a cheapie from eBay, so it might just not do anything. It came from a supplier called OK Catfair and cost a measly £3.28. They are very cheap because the thing about the Cat5 networks or Cat6, the Ethernet type networks, is that the stuff's really cheap because they're so common, but the actual science behind it is just staggering, like little transformers at each end of each twisted pair, and each twisted pair has different ratio of twists to avoid inductive coupling, and it's very complex. But anyway, enough of that waffle, let's actually open this up. It does have a warranty label which I've already ruined by running my fingernail across it. So we'll pop the screws out. I think this case just splits into two halves. It's a very nice case, I do like the casing. It looks as though it could have possibility for other projects. Okay, I'm guessing there's some sort of surge diode with the earth in the middle. How's this actually held in? Oh, I'm going to have to take a end plate off completely. Right. So there are 8 pins on each connector. I'm actually seeing a lot of these. Are these surge diodes or M7? They're just standard diodes. And then we got 2 what look like surge suppressors. They're both connected to the earth. I will say that the track that's connecting both those to the earth, they're not expecting a lot of fault current, which is not necessarily that great. Then again, I suppose that they're bigger than the other tracks connecting these. Right, I'm just going to pause and I'm just going to explore this. So that's it been thoroughly reverse engineered now, and it's quite interesting. I lifted one of these component leads up so I could see what was being used. And it's a device. It's basically a dual Zener diode in series. And this one is rated 6 to 8 volts, which means as soon as the voltage of about 6 to 8 volts plus the diodes that are also connecting all the pins to them is exceeded, it basically starts turning on. So let's say 70 volts, and it just clamps it down to that voltage to ground. But the actual circuitry looks like this. Each of the pins, each of the 8 pins has 2 diodes connecting to a common positive bus and a common negative bus, and it's just really, I suppose, it's the cheapest, easiest way of minimizing the number of these components, because these diodes, I should actually note what they are. Did I say they were M8? I think they were M8. M7 should I say? M7. M7. 16 of them. 16 times M7 diodes, so 2 connect each pin, and I suppose they're cheap. The transient suppressors are going to be quite expensive, and also they're quite bulky. So if on any pin, if there's a positive transient, say pin 3 gets a positive transient, a static discharge, something happens, that will get conducted through that diode to the suppressor. It will get blocked from the reverse direction by these diodes from going to the other pins, and it will get shunted to the ground. And this is why the ground reference is quite important. You want a pretty good ground on that. And likewise, if pin 5 had a negative transient with respect to earth that exceeded about the 70 volts, it would then conduct through this diode and go through this one. So it's just basically one for positive spikes and one for negative spikes, although each device is effectively a bidirectional device. And that's quite interesting. It's basically just the cheapest, easiest way they could get that level of protection, all the pins, and the protection is there. So ultimately, I wouldn't say, I wouldn't really expect this to survive much if it was struck by lightning, but for electrostatic discharges and, you know, fairly modestly high static discharges, I would say this is going to actually do its job. And the case is just really nice. It's just, everything about this case screams out, you know, make your own circuit board for Ethernet naughtiness and, you know, for something that goes in line. Whether that's stealing power over Ethernet or doing other devious things or interfering with the data, but let's not talk about that. But yeah, it's an interesting thing. It's quite a smart little unit. Definitely, the case must have other applications because it really is, you know, it's worth buying it just to, like so many of these products, just for this little extruded case. It's really smart.